Here we go on question number 3 from 2016. I'm going to do what I did with question 1 if you've already watched that video, which is I'm going to show you their rubric with their point system. I'm also going to show you mine because I tend to add a lot to my picture and to my work around it, and then kind of talk about what parts I thought were hard and what parts I thought were easy. So I tried to pick another one that, again, really common question. This time, instead of a table question, it's a very visual question where they have this graph of F, and then they tell you in the beginning of the problem the relationship between G and F. So I want to show you first my work of how I started this before I even really did any work in the actual parts of the problem. So here's mine. Don't mind me, I had to take a picture with my phone. So first thing I did is I wrote down what's the relationship between G and F. And so this comes from this given information that G is the integral from 2 to x of f of t. If I derive G and I get G prime, then on the other side, when I derive an integral, I get what I started with. So I end up with f of x. The variable does become the variable that's the boundary number. And then if I derive G again, giving me G double prime, then on this side I would get f prime. You will see questions like this a lot, and that is the first thing I write down every time, knowing full well that I may not use that for every part, but I'm going to use it kind of on and off throughout the question. The other thing I did is I figured at some point I'm going to have to do some sort of accumulation of area under a curve, something with an integral. So I went through and just kind of marked off each of these pieces. We have a whole bunch of triangles, so everything's 1/2 base times height. So my first triangle has a height of 4, a base of 2, so 1/2 of 4 times 2 is 4. The reason I put a negative is because it's under the axis, so that was just me noting where it was located. And then from here on out, the triangles are all really the same size. You have a whole bunch of little ones that are 4. So this together, 4 and 4, that piece would be 8, that piece would be 8, that piece would be 8, but it's below the axis, so it's negative, and that piece would be 4, below the axis is negative. So I wrote all that down. I didn't end up using it for a while, but those were some kind of like my beginning thoughts. So part A wanted to know, does it have a minimum? Does G have a minimum, a maximum, or nothing at all at 10? So the first thing I did when I looked at this is what's the relationship between G and F? So if I want G to have a minimum, that means I have to look at G prime. And does G prime equal 0 there? And that would tell me if it's even a chance, if it's a critical value. They didn't write a lot of work. I actually think my work was a little better explanation. The one thing I will notice about their point scale, if you wrote down that G prime is the same as f of x and you use that throughout the problem, they actually give a point just for that, just for understanding that relationship that I mentioned at the beginning, even if you weren't sure how to use that piece of information. So here's my work. I think it makes a little more sense. I probably did more work than I should have, but it kind of was helping me to kind of see the process. So I have that G prime equals 0. Is where I would have a critical value. So that means since G prime and F are the same, I want to know when F equals 0. So I looked at the graph. At 10, F does equal 0. It's one of the places where it touches the axis right here. So it could be a minimum or maximum. To figure out if it is, I want to see if the sign of the derivative changes. To be a maximum, it would have to go from a positive derivative to a negative derivative, or to be a minimum, it would have to go negative derivative to positive. Well, what happens is before 10, f of x, which is equivalent to g prime, is negative because it's under the axis. After 10, it's still negative because it's still under the axis, and that location is going to represent that slope. So my work, and you can write it in words, is I wrote before to x equals 10, you have a g prime or an f that's less than 0, and after you have a g prime that's still less than 0, so it can't be a minimum or a maximum because there's no sign change of the derivative. Part B wants to know if it has a point of inflection at 4. So point of inflection is the second derivative, so G double prime, which is the same as F prime. So I wrote that again. G double prime of 4, which is F prime of 4. What happens at F prime of 4 is you have a sharp point. So that's a place where the derivative is undefined, which means it could be a possible point of inflection. It has to happen at either when the double prime is 0 or undefined. So it's a definite possibility for a point of inflection. So then I want to check and see, does it have a sign change to see, does it go from a positive to a negative, which would be a sign change of a point of inflection or vice versa. So here's my work here. G double prime, which is going to represent F prime, which is the slope of the graph you're looking at, is bigger than 0 before 4 because it has a positive slope. It's going up, and less, and I wrote it wrong. It should say less than 0 after 4. So it is a point of inflection since the second derivative changes from positive to negative. I wrote the right thing here, but I didn't write the right thing here. So it is a point of inflection. We'll look at theirs. They just wrote it all in one sentence. It is a point of inflection since the derivative is increasing from 2 to 4 and decreasing from 4 to 8. I like my sign change example better. Then part C, I spent a lot of time doing part C, and I think when I looked at their answer, I actually spent more time than I should have. So part C wanted to know the absolute minimum and the absolute maximum on the interval -4 to 12. So when you're finding an absolute minimum or maximum on an interval, it's either going to happen at a critical value or it's going to happen at the endpoint. So -4 and 12 are things that you need to consider, plus any critical value that's between -4 and 12. So what they said, and I'll show you mine and how mine got really long, is that your derivative, your g prime, will only change signs at -2 and at 6. Because at -2, it goes from below to above, and at 6, it goes from above to below. So they considered those as the only potential minimums and maximums, and then they considered the endpoints, the -4 and the 12. What I did, I still think I get full credit, I just spent a long time, is I looked at every place where that derivative equaled 0. So my chart was huge. I went -4, -2, 2, 6, 10, and 12. I'm looking for the absolute highest one, that's my absolute maximum, and the absolute lowest one, which is my minimum. So here's how I get the answers. Here's how I get the g of x piece in this xy table. I need to use the area under the curve. So now this is taking that, when I check -4, that's making -4 the upper boundary of this integral. So that's asking you the integral from 2 to -4. First thing you'll notice is these boundaries are flip-flopped. So whatever answer I get, I need to negate it. So from 2 to 4, 2 to -4 is actually from here, -4 all the way to 2. So we have a -4 area and a +8 area, which just gives us a 4. However, because my boundaries were backwards, I actually negate it. It would be -4. So that's where this number came from. And then I did the same thing with -2. The boundaries are still switched because -2 would be my upper boundary. So from -2 to +2, I get an area of 8. However, because the boundaries are flipped, it should be -8. And then I did +2. Well, if you go from 2 to 2, if your boundaries are the same, you get 0. So that was the easiest one in the chart. When I put 6 in to go from 2 to 6, 2 to 6 has an area of 8, and those boundaries are right, so it's just 8. And then from 2 to, what was the next one I did? 10. So from 2 to 10 would be 8 minus 8. So you actually get 0 again because those would cancel out. And then finally, the upper boundary, 12, from 2 to 12, you would get 8 minus 4, which is -4. So now I have all these values, more than I actually needed. I'm looking for the absolute highest one and the absolute lowest one. My absolute lowest one is -8. My absolute highest one is +8. What they did on theirs is they made a shorter table, but still got the same answer as I did. You get 1 point for considering -2 and 6. If you consider more than that, that's fine. You get 1 point for considering the endpoints, and then you get 2 points for justifying. So a lot of points come from part C. And then finally, part D, actually all the work I did in part C made D so much easier. It wanted to know when I would get answers for G that are less than or equal to 0. So I actually used my table, and it saved me so much time. So I'm looking for answers that are less than 0, so negative answers are 0. That happens from -4 all the way till 2. 2, you actually get 0. And then it happens again at 10, and then ends at 12. So I wrote it like this. I wrote from -4 to 2 and from 10 to 12. It is allowed to equal 0, which is why I have brackets around these numbers. They wrote it like this with intervals with the inequalities. They said from -4 to 2, again, using the equal to in addition to the less than signs, and then from 10 to 12. If you have those two intervals, my guess is you get 1 point per interval is the way I interpret that. Then you get a point for each interval. D was much easier than C. C was definitely the challenge here. So this gives you an idea of how to do a question that is very visual and asks you to do a variety of things with derivatives and integrals. Again, really common AP question because it combines so many topics into one question. Again, if you have questions on this one, just reference 2016 number 3 so I know what you're asking about and I can clear up more if you need it. Have a great day.